Welcome to the 2025 PostgresWorld webinar series. Thank you for joining us today. Today we have the pleasure of hearing from Brian Fehrle. Brian will be presenting on upgrading the Mammoth, crafting the best path to modernize your database. Before we dive into the presentation, a few quick notes. This webinar is being recorded and will be available on the PostgresWorld website as well as our YouTube after the session. You're welcome to ask questions throughout the session via chat. I'll be reading these later to Brian during the Q&A session at the end of our presentation. With no further ado, I would love to join me in welcoming Brian Fehrle. Thank you, Brian.
Yeah, thank you, Debbie. Welcome, everybody. This talk is called Upgrading the Mammoth, like Debbie had said, crafting the best path to modernize your database. And first off, like I said, my name is Brian Fehrle. I am a Postgres database administrator and data architect all the way back to 2008. And when I first started with Postgres, the newest version was 8.3. And I was working on versions all the way back to 8.1 and initially started working on doing upgrades and noticing there's quite a few things that change from major version to major version. And 8.1 is very far, long time ago. I would consider that definitely a mammoth. But this talk is going to be talking about how we do major upgrades spanning multiple versions into a modern version. So I have a lot of this experience from working for multiple consultancy companies as well as a very big data company with hundreds and thousands of databases that needed upgrades. And I've learned a lot of different things you have to do for each of these databases and how none of them are actually the same. And there's always going to be something, a wrench in the gears that makes something odd. So one of the first things that we are going to go over and everything is what is a mammoth? And we'll get to that in a second. But the rest of this talk will also be talking over preparing for the big jump. If we are upgrading from a mammoth database to a newer one, there's a lot of things that we have to get ready for. Some questions that have to be asked, asking the right questions, and also figuring out what our yeah buts are. Anytime you try to propose something could be, yeah, but what about this? That puts a hamper in our plans. So whenever we have that type of stuff, we have to get clever, try to figure out our options, and think of the best way to approach the problems. And then at the end, I have a couple of real world examples that we can go over, and then we'll have our question and answers. So I will not be talking about every single upgrade path that can be taken, because I can actually think of many dozens. But we'll cover some of the main ones and some caveats and pros for each of those, and talk about what kind of problems that we can solve by getting clever. So the main thing about this is to learn how to write or ask the right questions, and then learn how to answer them and plan your upgrade. So first off, what is a mammoth? And I mean, it's pretty self-explanatory. It's an old elephant that's not around anymore, essentially. At this point, a mammoth is a database that is out of support in my mind, but there's people who are still running databases that are way out of support. Not just a couple months, not just a couple years, but sometimes much longer. So one of the things you got to figure out is, how you got there. Were you not paying attention? Time just flies by, or is management not allowing you to spend the time on upgrades? When you get to the end of life status, you'll notice that security issues will not be fixed. Even if they're there, no one's going to fix them. And you'll also be missing out on new features that could be making your life and your application a whole lot better and faster. So, like I said, there's an end-of-life schedule, and if you go to this URL for the postgres.org, you can actually see what the current end-of-life schedule is, and this is as of today. So you can see the latest version is 17.6, and that is final release will be November 8th, 2029. And you notice there's a lot of final releases in November, so usually we can expect a new major version of Postgres to be released about once every year, and pretty consistently it's been near the end of the year. So we're actually expecting a newer version, 18, to be coming out in the next few months, and I believe it's currently in release candidate 1 at the time of this recording. So it's pretty much coming soon, and also you can see 13, the latest version is 13.22. That is final release is November 13th. So at that point, 13 will no longer get any updates, and it will be starting to be considered a mammoth. And if you're on 13, now is the time to start planning your upgrade. So, first things that we need to do is start asking the right questions. When you want to do an upgrade, you need to understand the database that you're upgrading and pretty much everything inside of it in terms of its size, its complexity, all that. So first off, I always ask is how big is the database? Are we talking it's a couple hundred megs? This is probably going to be an easy upgrade. Is it a couple hundred gigs? More complicated. I've worked with databases where it was hundreds of terabytes that we had to upgrade. And that's where it gets pretty complicated because time is no longer on our side. How complex is the database? And complexity for me usually refers to, are there a lot of moving parts inside of the database? Do we have stored procedures that are written doing a bunch of complex calculations, loading data? Do we have partition tables? Do we have materialized views? Anything that's kind of above and beyond a standard table and index type of structure. Do we have 10 tables? Do we have 10,000 tables? I've seen it all. So we need to kind of understand the complexity of the database as we go forward. And that also includes the access patterns. When is this database access? Is this a website for just people in the US? That means probably over midnight or past midnight before 4 a.m. It's not that heavy used. Or is this an international social media platform where you're constantly being used all day long, no matter what? These are the kind of things that you need to know before going in. So one of the, or another thing is not just the database itself, but the entire environment, such as how many replicas, what are your backups, do you have any clones set up, do you have disaster recovery set up for different data centers? You need to look at the entire complexity of everything because when you do the upgrade, you want to make sure that it goes to everything. Another big question is what is your downtime allowed? This kind of goes back into when I said, the access patterns. Sometimes downtime is like, yeah, we can shut it down for an hour, and as long as we're back up, we're good. That makes life a whole lot easier for the upgrades. And other times, downtime is seconds. If it takes longer than 10 seconds, we're in trouble. And that's where we started having to get clever again. Another thought is what is the rollback? And again, if this is some sort of financial database where a lost transaction is disastrous, then we need to make sure that rollback is absolutely perfect and essential, and we have the ability to go back if there's anything wrong. Other databases may not be that important. Maybe it's just a blog, and maybe somebody's comment gets somehow lost or something. And if you want to gauge what is allowed to be lost, that answer could be nothing, absolutely nothing, and that's okay. And other things could be like, well, if we lose some stuff, it's fine. Based on that answer can also change some of our decisions that we make. And the last thing that I always bring up is, what is the infrastructure? One of the common things that happens when you are upgrading from a Mammoth, let's say we're on 9.2, which is a very, very old version of Postgres. There's also a chance that it's sitting on an operating system that also hasn't been updated in a long time, perhaps CentOS 5 or 6. Actually, I'm not even sure if I recommended 6, but there's also a chance where it's like, okay, well, if we're upgrading the database, maybe we want to also upgrade our operating system. Maybe we're also sitting on old hardware in a data center that's costing way too much money to uphold. So maybe you want to get into the cloud. So if we're changing the infrastructure as well, that needs to be considered in the upgrade plan. So once you start asking a bunch of these questions, I usually have like a questionnaire that I have clients fill out, and we have checkboxes and answers, yes or no, this or that, and that can give us a really good overview of what our options actually are for the upgrade. So at this point, we are preparing for the big jump, and this is a point we want to actually look at what our target database is. So I'm assuming a lot of people will have their current database in mind, what they're currently on. If it is a Mammoth, very old, then you probably know what features you have. So it's time to start looking at the newest version and say, okay, what can I gain from this? First off, we'll look at the feature matrix, which is on the postgres.org website. It's a very cool tool for first finding out what new features there are, but I also would use it to sell it to the higher ups if you're trying to convince them to give you time to do an upgrade. But then we also need to look at major things that have changed that you're going to have to account for when you do the upgrade. Not everything is just going to work out of the box like it used to. And I've highlighted a few things that you're going to need to look at and test to make sure that when you do the upgrade, you've already accounted for these major changes. So first off, we're going to look at the feature matrix. And again, this is at the URL at the postgres.org/about/feature matrix. And this is just a small example, but this is a small section where it shows the differences between major versions, and you can change which ones you want to compare. In this example, we're looking at the difference between 17 and 9.6. 9.6 is quite old, and you can see in terms of the partitioning and inheritance, there's quite a few differences. So each of these, well, not each, most of them are actually links that you can click on, and it'll take you to the documentation page that describes the technology itself. So you can learn about it, get more familiar with it, and also figure out if you need to make any changes. So this is a pretty great place to start. And like I said, I've seen many people who cannot convince higher ups or management to say, give me the time in order to do this upgrade. And a lot of times it's like, oh, there's no security issues, so we'll be fine. Well, you won't be, but maybe you can also sell them on cool new features that can improve business elsewhere. So one of the first things that has major changes when you're coming to a newer version is the backup options have changed. PG Backrest is a newer, well, to me newer, but it is quite a few years old. But PG Backrest is a very solid backup option that wasn't there a decade ago or longer when I first started. All of the backup options were custom written scripts using PG Start Backup, and there was an opportunity to break it and fail if you weren't paying attention. And PG Backrest is a very, very solid option that can replace a lot of that kind of stuff. So if you're looking at upgrades, I would also look at implementing PG Backrest as your backup option if you have not done that already. And like I said, PG Start Backup is something I used to use a long time ago to initiate backups. And they actually replaced PG Start Backup function with PG Backup Start in Postgres 15. And the reason is because it behaves slightly differently. Because it behaves differently, any scripts that are calling it could break based on the different behavior. So by renaming it, they force you to reevaluate your backup scripts. Or, like I said, adopt something newer like PG Backrest. But essentially, it will break older backups if it is using this method prior to PG 15. And since we're currently on PG 17 and about to approach 18, backups will continue to break if you're coming from a version prior to 15. The next one is replication. Replication options have consistently changed in pretty much every major version. Back when I first started looking at everything, the coolest and newest thing was warm standbys, where we would ship WAL files from the primary server over to a replica, and that replica would read it, but it would be in a warm state, couldn't even accept connections. If you're still running on something like that, yes, it works, but there's so much better options these days. So logical replication was added in Postgres 10, and it allows a lot more flexibility with replication. And there's also a streaming replication, which I believe that was, might have been 10 too. I can't remember the specifics. But the streaming replication makes that WAL shipping not needed, but still available. And the replication options have only gotten better over time, better performance, better ability to have the replicas as a read only and everything. So each major version gets better and better. So I would say take a look at any replication that you may have set up and look at your better options for going forward when you upgrade. Next major change is table partitioning is quite a bit different. Native partitioning was added in PG10, and before that it was basically custom using just inheritance and functions. So that still works, but native partition could actually just be a quicker and easier option to set up and move forward. And the performance of partitioning has improved going forward pretty much every major version as well. So some of the slower partitioning queries that you may see in 9.6 could be blazingly fast in 17 comparatively. So if you do have a lot of partitioning in your database and you're planning this upgrade, reevaluate the partitioning strategy and make sure that it's also tested very heavily. And I'm going to be saying that a lot here. Test, test, test. Test the partitioning. Make sure first off it works, and second off, compare the speed. Make sure that your queries are going to be a lot quicker. Next major issue, and this is going to be a few slides here, but we'll go over it pretty quickly. Common table expressions are different with Postgres after version 12. So some people use these a lot, some people not as much. But with a common table expression, prior to version 12, all CTEs were essentially materialized. So it would materialize the expression and then integrate into the query. After Postgres 12, it's not materialized unless you specifically say materialized. And it really depends on which you want, because sometimes the query could be quicker, but a lot of times it can also be slower. I've seen many cases where queries that were once fairly quick got slower just by upgrading the database. And in order to fix it, we actually had to go back and add the materialized. So we can take a quick look at kind of a query plan for before and after. This is using PG Manage. It's got a visual overview of the query plan. And we can see in one example, it's just a nested loop with 2 index-only scans. And then with the newer version, it is a nested loop with the CTE scan in between one of those index-only scans. So in this example, you can see it's just a maybe 20 millisecond difference in my little test scenario that I built up. But in real world, I have seen queries go from less than 10 seconds to over 10 minutes, just because the complexity of the query changed and the query planner, it wasn't built for the modern query planner. So like I said, it's actually a quick fix if you want the older behavior. You can see here 2 of the same query, the older one on the left where it just says with my count as, and on the right with my count as materialized. Adding that keyword of materialized will cause the execution plan to behave like it used to. So if you start doing your testing and you're realizing that your queries are extremely slow compared to what they used to, and it's common table expression queries, try throwing the materialized on there and compare it to the old behavior. The other option, obviously, is to also rewrite the queries completely differently so that it works better with the modern query planner. So next, and kind of the last thing to really bring up is to learn about JIT, just-in-time compilation. It was a new feature that was introduced in Postgres 11, and its default was off. So most people didn't even know it was there, probably didn't turn it on unless they were exploring newer technology and options for the versions. And in Postgres 12, it was switched to the default is on. And I'm not going to go too in depth with the just-in-time compilation description, but it does change the way things are executed by, and hopefully it makes things quicker. But I have seen some cases, not as much as the CTEs, but I have seen some cases where queries do get a little bit slower. And again, you can rewrite the queries, try to make them work better with the modern query planner, or you can turn off just-in-time compilation and compare the results. I have a couple of clients that I have worked with where we turned it back off just because their application was built and the queries were built without that technology there. So rather than rewriting everything, turning it off was the correct answer and getting our performance back to where we want it to be. So, but in general, it goes all over the place. It can make queries that were slower before much quicker now, or vice versa. Really quick queries all of a sudden are very slow. So that's another thing that you need to take a look at when you're doing your testing prior to your upgrade. And like I said, test, test, test. At this point, hopefully you have a newer version of the database up and running in an upgraded version, and you need to test functionality. You need to test performance. If you have backups, test your backups. If you have partition functions and triggers and functions, test those. If you have any type of anything in the database that does calculations, test them all. Data types, everything. Everything needs to be tested, because even if you read through all the documentation and update notes between versions, you could miss something, and you could not realize that, this change, which means my queries are different, which means my results page displays wrong data. And you may not know it because it may not give you an error message, but if the data is wrong, that's an error, and you need to be able to figure that out before you go live. So now that we've covered the questions that you need to ask before going for the upgrade, and then covered major differences that you're going to see when you get on a newer version, now we need to craft the upgrade. So based on all of the answers to the questions we asked before, size, complexity, etc., we need to try to figure out what the best answer is for the upgrade itself. And we'll do a quick overview of the major options and then kind of discuss about edge cases where we need to get clever and figure out another way to do something. So, and that's always with the yeah buts. So, I always say upgrades are easy until they aren't. I did an upgrade for a blog website, and the whole thing took under 2 minutes, and we were done. No questions, no issues. But it was a tiny database for just a WordPress blog. No issues there. But when you start getting into bigger databases and everything, you say, okay, let's do an upgrade with, say, PG Upgrade, which is our first option. Yeah, but it's a 10 terabyte database. That I tested it, and it takes an hour to do the upgrade. We can't be down for more than 10 minutes. Well, that's a yeah, but we need to figure out another option. And the main thing is it's all about the trade-off. You need to ask, how long will this take? What are the complications? And what's the trade-off? Like, what can I give up to make the upgrade better in this way? And sometimes you can give up some stuff, sometimes you can't. But ultimately, it's time, like I said, time to get clever. We got to think outside of the box to figure out what our best upgrade options are. So that's where we get clever. One of the reasons why we have this talk and this type of engagement and everything is because if you go look at the documentation on Postgres, as good as that documentation is, when it comes to upgrading, it's very, very limited. And the reason isn't because they don't want to document it. It's just because it is such a complex beast, you can't really document it. So instead of saying, here are the 10,000 ways to upgrade, we're here to say, here's how you think about it so you can do the upgrade yourself. You can see these 3 sections here is upgrading via PG dump all, and upgrading via PG upgrade, and then via replication. And the via replication one, this is the entire documentation, at least the last time I looked at it, probably about 7 months ago. This is the entire section of how to upgrade with replication. If you actually Google it, you'll find many blog posts, many talks of people going in depth about it. I've given one myself, and several other people at Command Prompt has talked about it as well. And this is actually one of the more common ways that we do it because it answers a lot of questions. But because the documentation is so light, we're here to talk about it more. Our first major upgrade is PG upgrade. And this is a binary that comes with Postgres, and it's easy. You point it to, you give it the parameters for your old database, you have the binaries and everything set up for the new one, you click go, and it'll upgrade for you. The pros is it manages nearly everything for you. Any type of changes that need to happen inside of the database, it manages. It will, the standard one, which is what we're talking about on the left here, it will copy all of your data from the old data directory to the new one. And it's fairly quick, depending on how big your database is. Because it is copying that data, imagine if you're copying 500 gigs from one drive to another, that's a limiting factor. So this is where you start asking, what's my downtime? And if your downtime is big enough that a PG upgrade can work for you, then great. The cons, though, is it could go badly. It could error. I've had a couple cases where they error and you have to go, let's go back. You bring up the old database, you get rid of the new one, and then you reevaluate. Obviously, if you're doing testing, you figure this out before you even get started, so you're not like freaking out or anything. But it can happen, and what that means is you have to bring up the old database and scratch the new one. If that database came online and accepted any connections and data from users, when you bring the old database back online, you don't have those changes. You cannot downgrade the database without actually just exporting that new data. So that's one of the cons is you cannot roll back with the changes the new database may have gotten. So with PG upgrade, there is also the in-place upgrade. And this is an answer to the problem of, a PG upgrade takes too long. an in-place upgrade won't copy the data to a new drive or a new directory, let's say. It'll use links, and it'll do some links, or I think they're hard links, but it does links from the old data files to the new data files and does the whole switch underneath the covers, and you're upgraded. The problem, it's much faster because you're not actually copying data. You're just doing a bunch of changes to the references. So it's a lot quicker. You can do a terabyte in a couple minutes. Um, the cons are it's much more dangerous because guess what? When you do this, you can't roll back. If it fails, you can't bring up the old database, at least not easily, with the old binaries and everything. So you have to make sure very, very much that it's going to work and it's not going to have issues. The next major upgrade option that we have is a dump and restore. And this one is just, again, PG dump comes with Postgres, and you can write a custom PG dump to export your data into either directly into a new database or into a file, and then you load that back up. The pros are it's highly compatible as long as you're using the new version of the binaries. It is always backwards compatible with previous versions of Postgres, usually up to a point. Again, test it. And you'll easily be able to import that data into the new database. I will say that when you do this kind of thing, make sure that stuff like functions, any custom functions written, also import correctly, because minor changes can make those not work. This is generally scriptable, so once you're testing it and you've got it all going, you can script the whole thing so that's not waiting on user input, and that can try to make it go as quickly as possible. One of the other benefits, too, is when you're doing this and a dump and restore into a brand new database, it's a freshly initialized database. So there is no legacy, any issues inside the database that may be brought over with a PG upgrade. Not so much of an issue unless it's something that's been around for many, many years. But it's like copying all your data into a brand new computer. It's always fast, it's always fresh, it's very clean. And you can also customize this type of upgrade as well. For example, if you want to ignore some tables, you're like, these tables aren't even used anymore. That can save me 500 gigs. Exclude them. Don't bring them over in the upgrade. And yeah, you have that kind of options too. So the cons are large databases does require long downtime. So if you are doing multi terabytes, it's going to take a long time to import all this data. You likely have to have all the disk space for your source, the backup, and your target. And if you're very large databases, maybe it's not feasible to have 100 extra terabytes just for an upgrade. So that's a limiting factor. And much like the previous upgrades, you cannot roll back with changes. If you bring the new database online, accept connections and data from clients, then if you have to roll back, you're bringing up your old database without those changes, unless you do something to find what those changes are and bring them back into your old database. That's, again, where you're going to have to get clever. Next option is logical replication. And again, this was introduced in Postgres 10. And there is an option for prior to 10. I think it goes back to 9.4. It's an extension called PG Logical. Very similar. The pros with this is its minimum downtime. You're able to set up replication from an old version of Postgres, let's say 10, all the way to the newer version, 17. And it replicates on a logical level. You can set up everything to say, I want all of these tables to be replicated. And you can have it caught up and be basically almost real time with all of your changes. And when it's time to do the upgrade, you bring down your application, you switch over, point to the application of the new database, promote it to say you are now the primary, and bring your application back online. This means minimum downtime. When you're up and running and replication is good, your downtime, even if it's hundreds of terabytes, could be under a minute. I usually shoot for 5 minutes just to give you some time. This is great for major upgrades. Like I said, you can go all the way back to 9.4 to 17 using this method. And it's great for data center transfers as well. If you are doing an infrastructure upgrade and you want to get out of, let's say you want to get out of iOS and you want to go to a new data center, you can have this set up replicating over, and your entire upgrade and data center transfer can be done in minutes. And the cool thing about this too is when you promote the new database to the primary, you're also demoting the old primary to a standby. So if you have to roll back, if something goes wrong and something's not working correctly, you can roll back and do the same exact method, but in reverse, and all of the data changes that our previous backup methods won't bring back are suddenly in your old database. So it makes it a whole lot easier to roll back, say something went wrong, let's go back to where we were and figure this out. The cons are it is more complex. Instead of doing a PG upgrade and it takes you maybe 5 minutes to kick it off, this could be a multi-month type of setup, depending on how complex your database is. It could require additional hardware and the storage and everything because you will have two running versions of the database at the same time, and just longer setup time. And it also has a requirement that all of your tables and relations, your tables, have primary keys or replica identities. And unfortunately, if your database is not designed super well and you have a bunch of tables without primary keys, this becomes an issue because you cannot replicate those either at all or easily. So the schemas must be compatible. Like I said, PG Logical is very similar to what we just talked about, but this is a way to be able to do it from before version 10. It is a extension by, I believe, Second Quadrant that allows us to do very similar behavior, but it lacks a few features and it's a little bit more strict about what your schema must be compatible for. So it's not as feature rich and everything, but we have used it to bring clients from 9.6 all the way to 17, and it worked great. And our downtime for one client was under 2 minutes, and absolutely loved it. After those, basically, if none of those are the correct answer, because there's always enough yeah buts to say this doesn't work, you have to start thinking of some other options. Sloaney is kind of an old project, and I'm not sure if it's even being updated that much anymore. But it is also a trigger based replication that can be used in the same way as the logical replication. To say we have the replication from the older to the new, we do a switch over, bam, we're upgraded. Bucardo, much of the same thing, totally different technology, same effective functionality. I even put in here triggers and foreign data wrappers. You can get creative if you want. You can say, okay, inside of these databases, we have a foreign data wrapper and some foreign tables. We're copying data over. It really depends on your data structure and how complex you want to get and what problems you're trying to solve. But these are some really outside of the box thoughts that I have for if you have no other options. But the other thing is a combination approach. You can say maybe for certain tables, because they're really active, I can use logical replication. But older ones, maybe archive tables, I can do a dump and restore later. Because of these are highly customizable, you can make it as customized as you want based on what your actual needs are, your needs for when the data needs to be available, and how long your downtime is, etc. So I have a couple of real world examples and can kind of go over those based on some of the topics. Yes, Debbie?
Could you perhaps address a question from Luke in regarding should he drop materialized view data before backup? Can you tolerate larger downtime for materialized views?
Materialized views, you're definitely going to need to factor in the rebuilding of those after you do the upgrade. If you're doing a PG upgrade, I believe it'll manage it under the covers. You don't have to worry about it. But if you're doing a PG dump, I would say you would exclude the materialized views data, but make sure that the new database has the materialized views set up and ready to go. And then once the data is imported via PG dump, you would do a rebuild of the materialized view, which could take time. Like some of those take a very long time. So that'd be part of your upgrade plan. Okay. So some real world examples. I have a couple of just kind of some loosely based on some upgrades that I've done, but also just trying to think outside of the box of things that may need to be done. This one here is customized to the access pattern. I'm in this example, I'm going from version 9.6 to 17. This is probably the biggest jump that we would have. And I have two different types of tables that I've kind of identified. The green ones are highly active tables. Let's say it's a comment system and people are chatting back and forth or messages. We want this to be real time because as soon as somebody sends a message, then the other person needs to be able to see it. So we can set that up for kind of a PG logical or logical replication to say these are being replicated to the new database in real time. We can also have, okay, there's very large, older partition tables, maybe history, maybe it's an ordering system of the past 20 years of orders on our web store. Well, how often are those accessed? Probably never, or at least very not often. So that's something that we could do in the background over time and not have to impact our actual upgrade. Another example is our changing infrastructure. And this is where we can say, okay, we are upgrading from a Postgres 11 into the cloud, and we're going to Amazon's RDS. With this, we can set up logical replication on all of our tables and migrate that over and have a real-time replication going straight to the cloud. And then when we decide to do the switch over, we would have a planned downtime and say, okay, switch over. The RDS is now the primary, and the old one is now the replica. And then we migrate our web application or whatever the application is to point to the new one. And then bam, we're upgraded. But we also have that option of down or not downgrading, but switching back to our older system if we have to. And here's one where kind of try to give a example of that switchover, where you can build everything simultaneously working with each other. In this example, we have Postgres 10, and this is where we're talking about having multiple moving parts in an entire project. So in this case, we have a primary database, we have a standby replica, and say maybe even a read-only replica. We have cases where your read-only replica is, serving up read-only queries for business intelligence or report generation, something where we just need to read the data, but we don't want to impact the primary database when it comes to like performance by bogging it down by very, very large analytical queries. So with this type of setup with logical replication, on the new system, we can build the same system as we have in the old one. So on the Postgres 17, we have, again, our primary database, a read-only replica, and also a standby replica or multiple standby replicas, cascading replication, whatever we need. And using the replication on 17, the incoming replication from logical replication is automatically replicated to everything. It's all in working order as you build this up. And once it's set up and everything, any and all changes that come into your primary Postgres 10 is instantly in the entire infrastructure in your Postgres 17. And all it's waiting for is for you to do that switch over. In this case, we would switch over just like this. Bam, we've upgraded. All of our consumers, our business intelligence, etc., are running off the new version of the database. Read-only replica is ready to go. It's up online. Standby replica is online. Our backups are already running. All that kind of stuff. And everything is also replicating back to our old one. Like I said, in the case we want to do a failback, we want to go back to the old version for whatever reason. And obviously, hopefully, that never has to happen. And after a while, when you say, okay, everything looks good, what you do is you uninstall that logical replication and you shut down your old servers. You're done. Your upgrade is complete. So, in summary, you need to upgrade. Everybody will scream at you if you ask questions about older versions that if you're not upgraded, then we're not going to help you, generally. Some people are a little bit more nice than that. But if you're having issues with older versions of the database, a lot of the times the answer is, well, the newer versions don't do that. Upgrade and you'll have better performance. You'll have less errors, hopefully. And it's just always a good idea to upgrade for security reasons, for stability reasons, and to also make sure that your data doesn't get corrupt. So again, you have to start off with asking the right questions. You have to know your infrastructure. A lot of these upgrades that I do, I'm coming from the consultant side. So I either barely know the database or I don't know at all. And I have to get used to it. So part of that is hunting around, looking for stuff myself, looking for complexity, but also asking the right questions. What is the access pattern on this? What is our downtime? What does it mean if something goes wrong and we're down for an hour? How bad is that? Sometimes that means, oh, it's annoying. And other times it could be like, cool, we lost $2 million. You need to know that before you get started so you make sure it doesn't happen. And once you have those questions answered and you understand your environment, you start to plot the best way to do the upgrade with the most speed, the easiest path, but also making sure that it's also very stable. Yes, Debbie? I think that might be all. The last thing is test, test, test. You have to test as much as you can and as whatever you think you can. Test speed, test performance, test functionality. Um, you can also do not just testing speed on single queries, but make sure that a database is ready to go in terms of being able to handle the entire workload that you're going to be throwing at it. Either if you have a test suite that can handle a stress test, make sure you do that pretty well. The second is to also make sure, or you can also use PG Replay, a tool that will take the logs of your database and replay them, and you can generate reports, query reports, and make sure, okay, this database is ready to handle the workload we're about to give it. So they're testing every single possible thing that you can think of, including like disaster recovery options, everything. Because the last thing you want to do is do an upgrade, everything looks good, and then a few months later you find out, oh, this wasn't handled correctly during the upgrade, so now we don't have backups, for example, something like that. So command prompt, we do this all the time. We've had many different clients have completely different type of databases. So we are always using this approach to say, what is the database? What's it look like? What's the best option to get it upgraded at the quickest and most stable or the most safe way? So at this point, I think we're ready to open up for any questions or any additional questions that we have.
Feel free to drop a question into the chat. In the meantime, I am going to drop the link to the YouTube channel for Postgres Conference webinars, which this presentation will be uploaded to there at a later time. And let's see, what else? Anyone else have a question from the audience?
While we are waiting for more questions, I will loop back to that initial question from Luke. Mm-hmm. Dropping the materialized view data before the backup, if you are doing like I said, a PG backup, it is so customizable that you can exclude that table. And actually, it should exclude it anyways because it is materialized view. But whether you're excluding it manually or if it's smart enough to exclude it, I actually can't remember if it does that. You would exclude that data because it's going to be rebuilt in the target system.
Brian, could you maybe speak to any particular gotcha that you haven't covered yet in regards to upgrading? Perhaps that people don't consider, maybe related to, I don't know, like extensions or anything with OS. Yeah.
One of the biggest is custom extensions. Postgres is so customizable that, I mean, you can write your own custom extensions in a variety of different languages. And I'm not just talking like writing a Perl or Python procedure language function, but actual extensions to the database. And they're extremely powerful and can solve a lot of problems, but they aren't going to easily translate. When you do an upgrade, Postgres won't upgrade that extension for you. So you need to make sure that it is completely compatible with the newer version of Postgres. I had one case where a database had these custom extensions, and because they were complicated and the people who wrote them weren't around anymore, we had to figure out how to fix them for the newer version. And that delayed our upgrade from the window allowed was 2 months to get it done. It took 2 years. And it's all because of those extensions. And unfortunately, we had to use them. They were an integral part of the application. So if there's any type of extensions or customization in the database like that, it's going to get more complicated.
So those extensions, would that actually extend to the OS as well in regards to any libraries, any consideration in regards to
that usually doesn't come up. I will say that if you are migrating, if you're for some reason running the database on a Mac OS operating system, there are some minor changes that people don't realize, like sorting. Your sorting algorithm is going to be slightly different. So when you say select from a table, order by this column, I don't remember the exact thing, but it's something in the case of, like, let's say nulls come before numbers come before vowels, and in Linux it could be different. So if you're changing infrastructure from major operating system to another major operating system, whether it's Mac to Linux to Windows, you're gonna have to make sure that stuff like that is acceptable, or you can fix it, because based on that operating system changes, you could run into some issues.
Great. Thank you so much. Well, we still have time for any questions that anyone may have. In the meantime, I'd like to remind everyone that we do that Postgres World and Postgres Conference webinar series as kind of a bit of a amalgam. It does have some webinars coming up, including an index strategy guide on October 9th at 4 p.m. Pacific time with Greg Destotny. And then also, that is a free webinar. Also on October 14th, Group Swim, Postgres Edition, the upgrade planning and end of year changes, which is, I think, a very really nice, compatible, complementary to Brian's talk today. This will be essentially just anyone who's looking for practical database support without cost. Come on in, get real time feedback. That is with the command prompt team. Keep in mind we do have quite a bit of support that we give to Postgres World and Postgres Conference, so that's why you see a fair amount from our team here today. But we also will have Dr. Ibrar Ahmed from PG Edge, who will be speaking on October 15th on scaling Postgres horizontal versus vertical. If you've not seen him speak, he is just an incredible wealth of information. Highly recommend that. That is free. As well as we have November 20th, SQL Team 6, How to Build Effective Teams with Dr. Aaron Cutshaw. Very popular. A lot of registrants for that already. And then also look out for a newly added 2-day paid training that's been added as well to Postgres World. There'll be more information going out soon to social media as well as to the newsletter if you're on that. But we do have another question. Yes, we
Yeah.
do have another question. Is it possible to achieve point in time recovery using only a storage snapshot in Postgres? Or do I still need wall archiving to reach an exact recovery point?
Uh, you will need wall archives if you want to reach any recover point after that snapshot and after the most recent, I believe, checkpoint. So I'm assuming storage snapshots such as like a snapshot on NetApps or something, saying here's a copy of that drive at that time. If you take a exact snapshot of that drive and then you try to bring that online, Postgres is going to come online and think that it's actually crashed. So it's going to say, okay, I need to rebuild as much as I can and come back online. So it will go to the data, it'll go to the most frequent checkpoint, and then from the checkpoint in its own wall directory, it will replay all the walls that it can as far forward as it can until it runs out of wall files, and then it'll come online. So if you're trying to look for actual PITR, I would not rely on snapshots. Snapshots work well as a disaster backup type of thing. But like I said, Postgres is going to think that it crashed. So if you instead want to say I want recovery to any point in time, the best option is to have a full wall archived from all those different um, files that have been committed and archived by the database in order to be able to do any type of point in time recovery. I think you might be able to restore snapshot and then stage wall files, but you might start getting into some issues where wall files on that snapshot were half written and you have an archived one that is fully written because it's been archived and saved somewhere else. So you might have to start playing with some. It might be a manual process for you to try to get that online. It's possible, but I wouldn't call it reliable.
Well, great. Well, thank you so much for that question. Is there any other questions? Let me just double check here. Okay, thank you. I do believe there'll be a blog post coming out soon that has to do with the PG auto failover issue. And one of the things that was talked about was when to use then. It was a issue with someone who didn't place the servers in maintenance mode, And so there's definitely some kind of like best practices that we'll have available on the command prompt blog very shortly, and kind of like one of those what not to do type things. And I do know that we talked about like cascading replication and about how when you could actually use thin snapshots as well. But thank you, everyone. I think that's probably it for today. Appreciate you being here and joining us. And with that, we'd like to say we hope to see you at the next webinar. Take care.
Thank you.